Can you solve this tricky geometry question asked in the SAT exam? We are given a right-angled trapezoid with longer base measuring 100 units. The top base is equal in length to this height, and this angle here is 30 degrees. And our goal is to find the area of this pink shaded trapezoid. You can pause the video and take a moment to think about it, and when you're ready, you can always come back to verify your answer. Alright, let's solve it together. But before we begin, let's define the top base of the trapezoid as x units. And since this height is equal to the top base, that means this height is also x units. Now let's drop a perpendicular from the top right corner of the trapezoid straight down to the longer base like this. Since height of trapezoid is x units, that means this vertical line is also the height of the trapezoid, so this is also x units, and this bottom base is also x units, giving us a square. Next, let us focus on this triangle. We are told that this angle is 30 degrees, and since these vertical and horizontal lines are perpendicular, this angle here is 90 degrees. So by subtraction, this third angle in the triangle must be 60 degrees, right? In any 30, 60, 90 triangle, the side opposite the 30-degree angle is always half the length of the hypotenuse, and the side adjacent to the 30-degree angle is always the square root of 3 times the opposite side. So if this is x units, that means this hypotenuse is 2x units, and this adjacent side must be x times the square root of 3, correct? Now focus on this bottom base of trapezoid. The total length of this base is given as 100 units. That means this square's base of x units and this triangle's base of x times the square root of 3 is equal to 100 units. Now taking x common from this, we get x times the quantity 1 plus square root of 3 equals 100. And dividing both sides by quantity 1 plus square root of 3, we get x equals 100 divided by the quantity 1 plus square root of 3. Now to simplify this, we will rationalize the denominator by multiplying both the numerator and denominator by the quantity square root of 3 minus 1. So that gives us x equals 100 times the quantity square root of 3 minus 1 divided by the quantity square root of 3 plus 1 times square root of 3 minus 1. Now using the algebraic identity difference of squares, that is, quantity p plus q times the quantity p minus q is equal to p squared minus q squared, we have the denominator as square root of 3 squared minus 1 squared, which is 3 minus 1, or 2. So dividing the expression by 2, we get x equals 50 times the quantity square root of 3 minus 1. Now we have everything to calculate the area of this trapezoid. Area of trapezoid is calculated by the formula 1/2 times the height multiplied by the sum of the two bases. In our problem, the height is x, the top base is x, and the bottom base is 100. So substituting those into the formula, we get area equals 1/2 times x multiplied by the quantity 100 plus x. Again, substituting x as 50 times the quantity square root of 3 minus 1, we get area equals 1/2 times 50 times the quantity square root of 3 minus 1 multiplied by 100 plus 50 times the quantity square root of 3 minus 1. Now let us simplify this step by step. Taking 50 common from this expression, we get 50 times the quantity square root of 3 minus 1 multiplied by the quantity 2 plus square root of 3 minus 1, all divided by 2. This 2 plus square root of 3 minus 1 is square root of 3 plus 1. And 50 divided by 2 gives us 25. So now we have 25 times 50 times the quantity square root of 3 minus 1 multiplied by the quantity square root of 3 plus 1. Once again, applying the difference of squares formula to this square root of 3 minus 1 times square root of 3 plus 1, we get 3 minus 1, which is 2. Thus we have area of trapezoid is equal to 25 times 50 times 2, which equals 2,500 square units. And that's our final answer. Pretty amazing, right? Even though we did not know all the side length of trapezoid, a little geometry and algebra helped us find the exact area. But wait, before you go, I have a quick bonus challenge for you. Can you find the area of this same trapezoid in terms of a variable x instead of 100 units? Think it through and drop your answer in the comments below. Let us see who can figure it out. If you found this explanation helpful and learned something new, don't forget to hit that like button, share it with a friend, and subscribe for more mind-bending math questions. Thanks for watching, and I'll see you in the next video.